Hey, hello, good morning, guys, and this is Karan with Gautam. And guys, today we will be doing part 6 of the Emotion AI model. Today we're going to be covering basically the data visualization, and we're going to learn how a matrix works, confusion matrix works. So, let us dive in. So, first, we do the score equals. So basically, do accuracy testing. This line evaluates the performance of the model to emotion on test data X test and the correspondence to labels Y test. The evaluate function typically returns a list of metrics depending on the model type. Here we're capturing the second element of the list using score 1, which likely represents the accuracy. Then we print it with formatting, and then it shows that we have about a 72% accuracy with the old trained model, and we have a 72% loss. Then we can see that history to history keys, this line retrieves all the metrics tracked during the training and stored in the history object. These metrics include accuracy, loss, value accuracy, and value loss. Then, these lines extract specific metrics from the training history. So basically, we get the accuracy, we get the val accuracy, we got the loss, and we got the val loss. Then, so now we just plot and the validation performance. This line creates a sequence representing the training of the epoch. So this basically prints accuracy. It uses the length of accuracy, which should reflect the number of training epochs, to generate the range of indices. Then you plot, you basically just, you use matplotlib, and next thing you plot epochs, and then you plot accuracy. BO means blue circles, and X and B means blue, and next thing you just add the label, and then you have this plot. So we can see that we started from 45% accuracy all the way after training for 15 epochs. We have got to about very high amounts, but then the difference between the validation accuracy is that the accuracy on the training data and then the accuracy on the validation data. So we can see we could have hit 80% on training accuracy, but the validation accuracy not so much. So we can see that overfitting is a problem. We can see sharp increase, but then why does it decrease as we do more epochs? This is the problem known as overfitting, where the data is too fit to the model and then it just doesn't work accurately. Then same logic, just the loss, the lower the loss the better, but then same thing, we can see the loss actually go up, which is also another disruption in the flow of the data and an outlier when we usually see the loss going down. Then we predict the class labels. So basically, predicted classes. This line predicts the class labels for test data. And next then, so model 2 emotion predict X test generates probability distributions for each data point across all possible classes. Then np.argmax, along with the last axis of x-axis equals to -1. This finds the index of the maximum value in each probability distribution, effectively converting them to predicted class labels. Then yTrue, this line extracts the true class labels from yTest in a similar manner as the previous line. So basically you assume that then, so it basically, this line extracts the true class label from yTest. Then you just check the shape. Then when you do the confusion matrix, this line creates a confusion matrix by comparing the true labels with predicted classes. And then the heat map, you basically just plot the heat map, CM, basically the confusion matrix, annotations is true, and next in the bar, C bars is false. And so let's understand the heat map real quick. So overall performance. The heat map provides a visual summary of how well your model performed on the test data. Ideally, you want high values on the diagonals and zeros everywhere else. This indicates that the model accurately classified most data points. Class-wide accuracy. So basically, by looking at the diagonal entries, you can assess the model's accuracy for each class. High values on the high diagonal correspond to good performance in these classes. Conversely, low values indicate the model is struggling to predict those classes correctly. So these are basically our emotions, 0, 1, 2, 3, 4. Let's quickly go back and just review what these were. Okay, so let's just get these real quick. And next then put it down here so this can aid us. Okay, so 0 anger. So we can see on the anger, we're able to define anger pretty well. We're not able to define disgust, which is a place we need to improve. We have a really low value for disgust, which is not good. Then sadness and happiness, we're able to predict pretty well, and surprise we're also to be able to predict well, but not as well as anger. So we can see that we really need to work on our disgust predictions. So the off diagonal entry shows where the model is making mistakes. If a particular class has high values off the diagonal, such as here, it means that the model is frequently misclassifying that class. So you can see it's frequently misclassifying sadness into anger. And then also we can see that it's also sometimes misclassifying sad happiness. It's misclassifying happiness as surprise. So then for more in-depth analysis, you can see that what classes are most confused with each other. So now this is the quiz. I'm gonna guys ask you 3 questions. Please respond in the comments. So first, which class are we grading the most accurately? 2, where is the most misclassifying between classes? And 3, what emotions is the model biased towards? After answering these questions, you can clearly understand how to read a confusion matrix. Then we have the prediction and anger. So we have anger, sadness, happiness, sad. We're doing pretty well here. We have lots of accurate predictions, but then we can see some misconfusion, such as we're predicting sadness. It says the prediction is sadness because you can see that like her face is not actually smiling a lot, but the truth is she's happy. Then we can see the prediction is happiness, but she's actually angry. Same thing, we thought surprise because of how he looked, but then it was actually happiness, and same thing. So this is how to create an emotion AI model that can effectively help you predict emotions from a certain image. Then tomorrow is the last day. We're just going to just like wrap everything up, save the model, and just show how to export the model. So this is it, guys. Thank you guys for watching. Just 1 more days in the series. You are learning how to make your AI using Keras and TensorFlow. Thank you guys. Don't forget to like and subscribe. This is Coding with Gautam, and out.